Welcome back. Today we're going to look into distance of a line segment. Now, before we delve deep into an example and so on, let's go through how did the formula come about, right? I know you guys don't know the formula at the moment, but this is how. So we need to figure out why and how it came about before we use that formula, okay? Just like in any mathematics, you need to go the long route before you go to the very easy part. So let's consider that point A 4, 1, right, and point B 2, 5 are plotted on a Cartesian plane, which is a part of a Cartesian plane right here, right? Let's try and plot it. My point A 4, 1 should be right here, so I'll label that as A. My point B will be right here. Once I've plotted it, let's draw a line and connect that dot, right? I'm going from point A to point B. That's my line. I need to find the distance or the length of that line. Now, to figure out the length of that line, right, there's actually another way for me to get from point A to point B without going through it directly, right? One of the ways is going from point A and going across, right? And then going up. See here, it kind of looks like it is a right angle triangle, right? What do we know about a right angle triangle? How do I solve for one side, the length of one side? We'll have to use Pythagoras' theorem, right? So Pythagoras' theorem is c squared equals a squared plus b squared. We know that. But I'm pretty sure you're thinking right now, well, how do I find the length of A and B, right? To figure it out is, first off, think about it. My coordinate B is 2, 5, and my coordinate A, or my point A, is 4, 1. How do you think I would be able to get this length right here? Well, if I look at it on my Cartesian plane, point B starts from 5, and it needs to end up to 1, right? Well, I need to do 5 minus 1. So my length for this will be 4 units. Then my length for the bottom part, or for my B, right, it'll just basically be, I start at 4, and I'm going to 2, right? I'm starting from 4, going to 2. Well, I need to do 4 minus 2, which gets me to 2 units. Well, let's put that in now, right? I know my A and my B, so let's sub it in. My C squared will equal 4 squared plus 2 squared, right? That will be 16 plus 4 equals to C squared. 16 plus 4 equals to 20. So C squared equals to 20. To get me to just C, I need to square root it. So my C would be root 20 units, right? Because I don't know if it's centimeters, meters, or whatnot. Units is just a general term. So let's delve deep into this, right? How did I find my A and my B? Well, I found my A and my B from doing, let's focus on my A, from my Y2, so my bigger number, minus my Y value that is my smaller part, right? In this case, I would do, to get A, it'll be Y2 minus Y1. My bigger number minus my smaller number in this case. For my B value, it's the same thing, but now it's not my Y's, it's my X. It'll be my X2 minus my X1. Okay. Keep this in mind when we look at the formula. Okay, hopefully this makes sense. Let's look at the formula now. So my formula is actually, from what I gather here, is I need a square root, right? So let's put that in first. I need to have a square root because every time I have to use Pythagoras, I need to go from c squared to now just c. To get rid of that squared, I have to square root it. Then I need to find my values for a and my b. What did we say? We said a equals to my bigger y value minus my smaller y value, and my b will be my bigger x value minus my smaller x value. So that's what I'm going to do, right? I'm now going to put it in x2 minus x1. Because it's Pythagoras, right? I need to have this squared. Okay? So it'll be whole squared plus my b, which is y2 minus y1 whole squared. Right? That's my formula. That's how my distance formula came about. Okay, now one thing that you need to be careful about when figuring out the distance formula is that you need to be careful when dealing with negatives, right? A coordinate such as -2, -3. And one thing that we just touched on was that if it doesn't come with a specific unit, just use the general term square root 20 units. All right, let's go quickly into our first example here. Find the length of the segment joining -1 and 2 and 4 and -1, correct to 2 decimal places. Okay, let's rewrite our coordinates or our points. I'm going to write down -1, 2 as my point A and my 4, -1 as my point B. Once I've done that, just like our previous lesson for midpoint, I'm going to now label x1, not x1, x2, x1, y1, and x2, y2, right? Because in my formula, I needed to find out which one's my x value or my x2 and which one's my y2 and y1 and so on. Okay, so I've labeled that. Let's write down the formula. Okay, x2 minus x1 whole squared plus y2 minus y1 whole squared. All I have to do now is substitute. Okay, so my x2 is 4, this one right here, minus, be careful here, my x1 is a negative, so I'm going to just put a small bracket here, just to keep it, I guess, cleaner, and I can see what's happening. I'll whole square it, and plus my y2 is -1, minus my y1, which is 2, and whole square it. Now, all you can do now is put this into the calculator. Yeah, if it makes it a bit more confusing by having these negatives, right? All you can do is remember what a negative and a negative turns into. Well, a negative and a negative turns into a plus, and you can rewrite it before you even put it into the calculator if you would like. It'll be 4 plus 1 whole squared plus -1 minus 2 whole squared. Once you put that into the calculator, you should get this as your value in decimal places. And I want it to be in 2 decimal places. So it should be 5.83 units. Hopefully that makes sense. I'll see you next time. Bye.